Hi everyone, my name is Suvarnade Bappan and today I'm presenting my paper titled Autogenics Automated Generation of Context-Aware Inline Comments for Code Snippets and Programming Question and Answer Sites Using Large Language Models. And the paper uh, has been accepted on the 24th IEEE International Conference on Source Code Analysis and Manipulations Camp 2024. So here are the outlines of my presentation. We everyone know that source code comments are crucial for enhancing code comprehension, but unfortunately, code snippets in programming question and answer sites like Stack Overflow open lack of comments, and this can lead to several problems for developers and users in that platform. There are numerous factors that contribute to the absence of comments, such as Stack Overflow participation is voluntary, developers face time constraints due to their tight schedules, and manually adding comments is tedious and also monotonous. Another fact is that snippets on Stack Overflow are typically brief statements, not full methods. So inline comments fit better in this context rather than method level comments or other types of comments. And there is growing research on automated comment generation tools. So what is inline comment? An inline comment is a single line comment typically used to explain or clarify a specific line of code. For the Python, it starts with hash, and for the Java, it starts with two forward slashes. Here is an example of method level comment. Here you can see that method level comment actually explains the functionality of a whole method, whereas the inline comments in the right hand side, you can see that it actually explains the functionality of a particular line of comments. There are numerous reasons that drive us to conduct these experiments. The first reason was more than 582K answer code snippets have neither inline comments nor explanations. So there is a necessity for automated inline comment generation tools for enhancing the documentation in Stack Overflow platforms. And Stack Overflow code snippets often lack usability, which leading to misuse. Also, developers find undocumented code frustrating, and it also can negatively impact on a Stack Overflow post score. Prior studies mostly focus on method level comment generation, so there is a research gap for automated inline commenting tools on Stack Overflow. Here you can see an example of a Stack Overflow answer where a user commented that why don't you explain code a bit more? And it might also negatively impact the post score. Here you can see that the post score was 0. There has been done numerous works on automated comment generation, like Ayer et al. Introduced RNN networks with attention mechanisms, whereas Wu et al. Developed deep com to enhance comment quality by considering both semantic and structural information. And to improve that work, Leclerc et al. Introduced the AST Attend-to model, which incorporates standard encoder-decoder framework enhanced by an additional encoder for a flattened AST using the structured uh, traversal technique. So the primary goal of our study is to bridge the existing research gap by developing Autogenics, a browser plugin that can effectively integrate it to Stack Overflow to generate effective and context-aware and noise-free inline comments. And to achieve that objective, we formulated three research questions. In the first research question, we explored how effective LLMs are at generating inline comments for code snippets found in programming question and answer sites answers. In the second research questions, we will explore how developers perceive the comprehensibility of code snippets with the presence of inline comments. And in the third and final research questions, we will explore the feasibility of integrating a browser plugin into Stack Overflow platform for generating context-aware and noise-free inline comments for code snippets. And moreover, we also explore whether these comments are more effective than those generated by conventional large language models. So our contributions are threefold. At first, we manually evaluate the effectiveness of LLM-generated inline comments, and then we conducted a survey for getting the developers' perceptions. And finally, we developed a browser plugin named Autogenics. Here is an overview of our entire research methodology. At first, from the Stack Overflow, we collected the answers, actually accepted answers related to Java and Python, and then we sampled uh, a random subset to to filter out the target code snippets. And then we utilized the large language models such as GPT-4 and Gemini 1.5 Pro for generating inline comments for the code snippets. And to answer the first research questions, we evaluated the effectiveness of those LLM generated comments. And for answering the second research questions, we took a random subset from our entire data set and provided them into survey participants for getting their viewpoints regarding the effectiveness of those comments. And to answer the third research questions, we integrated an automated tool, and later we also evaluated the effectiveness of our tool to assess whether it actually enhanced the quality of inline comments in Stack Overflow platforms. So our entire research methodology actually divided into 5 steps. Dataset preparation, then inline comment generation, then inline comments effectiveness evaluation, and then developer survey, and finally the development of an automated tool named Autogenics. So in the first phase, like in the dataset preparation phase, we collected accepted answers related to Java and Python from the Stack Overflow, and we considered only the single code snippets. Then we divided our entire dataset into 4 quartiles based on lines of code, and then we took a random sample subset from each quartile to create our final dataset of 400 code snippets. Among 200 are from Python and 200 are from Java. And in the second phase, to generate the inline comment, we applied Gemini 1.5 Pro. And later, we also conducted a case study using GPT-4 to compare the quality of inline comment generated by both of those LLM models. And to evaluate the effectiveness of LLM generated inline comments, we considered 4 metrics such as accuracy, adequacy, conciseness, and usefulness. And in the fourth phase, we conducted a developer survey. Here you can see that most of the survey participants are quite experienced. Like here you can see that uh, over 57% of survey participants had 3 to 5 years of development experience. And here is the uh, system architecture of our Autogenics tool. Here you can see that client server uh, actually pass the answer code snippet and question text to the uh, backend for generating inline comments, where the backend server which developed using Flask received those answer code snippet and question text and divided into 2 parts. The question text feed into Gemini 1.5 Pro model to generate the code context, and later that code context along with answer code snippet feed into Gemini 1.5 Pro model again for generating the context or inline comments that were further fed into the noise filtration mechanisms, where we utilize the regular expression and some pattern matching techniques to filter out the unnecessary comments for some statements such as import statements and print statements. And finally, we got the output of context aware noise free inline comments that uh, passed into the client for users. And you can see the results of the research question 1, and you can see that the accuracy, adequacy, consciousness, and usefulness of all 4 metrics are quite good. And that was true for Java and Python both. So Gemini 1.5 Pro model generates highly accurate and adequate inline comments, especially for moderately longer code snippets, such as you can see that in the third quartile, the comments quality was excellent compared to other quartiles. And we also conducted a case study using GPT-4 where we saw that GPT-4 access with comparatively shorter code snippets. But since Gemini 1.5 Pro is cost effective and performs comparably with GPT-4, we considered Gemini 1.5 Pro model for developing our tools. But there is a problem with the conventional LLM models. Like often They generate comments that are generic and sometimes noisy. So in the research question two, we have seen that like most participants found LLM generated inline comments as effective, and that observation aligned with the uh, output of the research question one. And there was also a growing demand for automated inline commenting tools, especially the browser plugin. Here you can see that among 78.6% of developers were interested in automated inline commenting tools, whereas most preferred the browser plugin. In the third research questions, we compared the LLM generated inline comments uh, with our Autogenics generated inline comments. In the Autogenics, we passed the question context and we also introduced some noise filtration techniques. And when we compared the quality of uh, these two techniques, like here you can see that uh, the quality of inline comments generated by Autogenics was better compared to the conventional LLM models in terms of especially the accuracy and adequacy metrics. So comment, we can say that the comment quality enhanced significantly, and that fact was evident for both like Python and Java both. And here you can see an working example of our tool. Like in the right hand side, you can see the comment generated by standard large language models without context. Here you can see in the line number 5 and 7, they generated some unnecessary comments for the print and control structure statements. But the left hand side, you can see the output of our Autogenics tool. It effectively filtered out those unnecessary comments. Moreover, conventional LLM models actually couldn't identify the inherent meaning of the variables. That was evident in the line number 3 and line number 4. Here you can see that it couldn't identify the inherent meaning of Y train 1 and T1, whereas our tool effectively identified the Y train 1 meaning as training set and T1 as an indicator matrix because it got that context from the code context it generated from the question description. So uh, this actually this is the difference from among our tools and the conventional LLM models output. So in conclusion, we can say that LLMs improve in accuracy and usefulness with increased code length, but struggle with conciseness. And the survey supports that observation. And the survey shows the demand for automated tools. And we have finally seen that Autogenics can assist developers in code comprehension tasks by enhancing the lim conventional LLM models output. And in the future, our aim is to expand research to more languages and gather user feedbacks. So these are the reference of our study. And yeah, so thanks everyone.